Hello and welcome to Wolt Tech Talks podcast. My name is Jerry. I'll be your host today. We are back from a short break, but we are bigger than ever. As you can see, there are 4 of us all together. So this will be more of a panel discussion than a podcast of a single individual. Today we will be discussing our machine learning platform, or ML platform as a shorthand. And we have 3 guests. Stefan from a machine learning platform team. Stefan is a developer relations engineer. Miia from machine learning platform team as a machine learning engineer. And then we have Kasimir or Kassu, who is a data scientist. So we have basically 2 from the platform side and then Kassu from the user side. So I'm sure we will hear some interesting insights for the whole life cycle of our machine learning platform. Should we start with short introductions? Who would like to go first?
So yeah, I'm Stefan, developer relation engineer at Wolt. I've been at Wolt for around 3 years now, actually. And I was the first ML engineer of the ML platform. And since then I moved to developer relation engineers to basically help our data scientists and, make sure that they know the work we do, the work we produce. They know how to use the platform and different things like that. So that's it for me.
I can go next. Yeah, hi, I'm Miia Niemelä and work in the same team with Steven as a machine learning engineer. I joined Wolt about 1.5 years ago when we started the team, and before that it existed as a side product of another team. So yeah, building their things and trying to make life easier for data scientists at Wolt.
And finally, hi, I'm Kassu. I'm a data scientist at Wolt. Been here for 2.5 years and been working the 2.5 years at the logistics team embedded there. So producing all sorts of time estimates using the glorious ML platform team that these 2 magnificent people are building. And yeah, I've also being there to sort of witness the journey from, being a part of another team. And then, 1.5 years ago, what Miia just said, like the number of the people in that team grew and you became a dedicated team. So cool.
Great. I'm sure we'll get to the journey part, how things evolved, but could we start with something easy first? So could someone explain me what an ML platform actually is? What does it mean?
Yes, so it's basically like any platform team exists for same reason. So in our case, there are teams involved that are building their data science involving products, machine learning models, and they are trying to solve the same problems over and over again in different teams, like where do I run my model training pipelines, how I store the experiments, how do I build the service around this model, and how do I monitor the predictions, and so on. How can I use GPU to train my models? So I think our team's goal is to reduce the cognitive load of these teams so that they can focus on things that bring more value to the business than figuring out, like, for example, which tool to choose for which purpose. Yeah, so I think we are kind of aiming for the teams to own their products end to end. So there's no separate dev team that hands over the model to QA team or release team, but we are trying to enable them to own it end to end.
Yeah, I think there's sort of a trend with this platform teams at Wolt at the moment. So I guess we have grown over a certain scale, and now it's time to kind of platformize things in order to individual product teams to be able to ship faster with higher quality and maybe a bit more standard. How about, I've heard this, maybe a buzzword, MLOps. How does ML platform relate to that?
Yeah, I think that MLOps is quite crucial part of ML platform. So as you said, I think it's quite a buzzword. But I like to think that it's basically applying DevOps principles to ML. So trying to unify the development and operations of developing ML systems. But in addition, there are some more things in the nature of developing machine learning systems that is like different to the traditional software. So maybe Kassu can tell more because that's his job. He does that every day. But the development of systems involving machine learning models, it's quite iterative by nature. So it's not like you have this specification that you need to implement, but it's actually like finding out the correct data and figuring out the features and how does the model act. You iterate and you experiment with the different kind of features. You need to register those experiments. You need tooling for that. You maybe need to revisit something you did earlier. So it's not really that straightforward. And also ML models are quite dependent on data that comes in. So it's not like you build it and it runs forever, but you need to keep monitoring them. You need to understand if there's something changing in the incoming data that you can react and keep the predictions reliable. So for example, these kind of challenges we aim to tackle with the tooling that we provide and best practices in the ML platform team.
Right. So if I understand correctly, I could loosely compare DevOps to MLOps, but there are like some differences as well. So cannot like completely say they are one-to-one traditional software DevOps and MLOps in ML engineering related practices. All right, should we dive a bit deeper to the ML platform that we have? So I believe Stephen has seen the evolution from the get-go. I believe you were already part of Wolt when we didn't have any kind of platform. So could you share what was the decision point? Like, what was the motivation that, okay, now we want to move towards a platform solution? And how did it evolve over the years up until this point?
Yeah, I think it's like, I mean, as Miia said before, it's the idea first was to really avoid having people like redoing the same thing all over and over again. You don't have to think about the different toolings and different things like that. So it was really the way we wanted to approach it, which is also quite a Wolt way, if we could say, always have like people doing things end to end. So that was the idea. And then before we had an ML platform and before we had like ML tools, we had something like, I don't know if I remember correctly, but like 5 or 7 data scientists. But putting things into production was quite challenging for people. They would like train their models, but sometimes would struggle with deploying models into production, especially as the ML platform and has the entire stack of Wolt on Kubernetes. You don't really, as a data scientist, you don't really like, oh yeah, I love using Kubernetes. I really want to learn about it. You don't really go through that feeling usually. So the idea was like, oh, how can we abstract Kubernetes away so people can deploy things easily? And that's actually how we started the ML platform, was that the biggest problem people had was deploying things. So then we tried to figure that out and to solve that with different tools that we have. So then we started using Seldon Core, which is an open source product that basically helps you deploying models and create microservices on Kubernetes. So that's how we started. Then we hired a lot of different data scientists, and then we created the ML platform team to actually like address the problems of data scientists.
Great, thanks. Maybe if we can go a bit deeper into the stack, you mentioned Sheldon Core already. What are the other ingredients of the ML platform? No need to go like in a historical order, but maybe if you can describe how it looks like today. I'm sure it has evolved over the years quite a lot.
Yeah, for sure. So yeah, as I said, we started with Sheldon Core to deploy it onto Kubernetes. Then we also, or before that, we actually had MLflow, but MLflow is, just a database with a fancy UI, basically. And then we also had to figure out how to train models, because deploying them is nice, but you also want to train them. And we wanted to train them still on the platform, still on Kubernetes, so that people don't have, to redo everything. Like instead of going from a notebook to Kubernetes, they wouldn't have to redo everything. So then we looked around, benchmarked different solutions. Then it kind of came down to Kubeflow versus Flight. And I'm not the biggest fan of Kubeflow, if I may say, on my personal opinion. I really like the idea. I find that the way to use it is very, very hard, especially as a data scientist. I was evaluating it, and then I had to sell it technically to a data scientist, and I was like, oh, if I struggle myself, then if I have to sell it, then people will probably be like, well, I don't really care about it. So then we went with Flight, because also it's open source and it supports different languages and it's Kubernetes native. So yeah, then we went with that. And that's basically the base of the ML platform, having Flight to train your models, and then register them in MLflow and then deploying with Sheldon. And now we have probably Miia can talk a bit more about that, but when we are building now and building for the future. But yeah, that's how we started. And also, yeah, to add, everything we use is open source. That's kind of a philosophy at Wolt as well. So we don't only use it, we also contribute back if we have things to improve or things that are you have bugs. It's a big part of Wolt, and that's also something that is very, very nice as an engineer when you work here.
And how are the numbers currently? You mentioned that there was a bit more than a handful of data scientists back in the day when we started to build the ML platform. How is it currently? How many ML engineers we have, and what's the ratio towards the data scientists?
Yeah, I think if I remember correctly, we have around 50 to 60 projects on Flight. So projects that are either trained on Flight, or you have batch predictions, because also you can run batch prediction on Flight if you then write your prediction somewhere in a database. Then now we have something I think 50 data scientists. Overall, over all the different teams, we have 7 people in the ML platform team. So I have a master in math, but we stopped using numbers at one point. So I'm not really good with numbers, but I think we have around 7 data scientists per machine learning engineer. So that's what we have at the moment. And yeah, back then it was actually the same. It was 1 for 7. So
yeah, around the same ratio. The scale is just gotten a bit bigger.
Exactly, yeah. And I think we have something 15 models running in production for real-time predictions. Around 15, I think, last time I checked.
Yes. Would be interesting to hear kind of the similar version of how the journey has gone from custom-made things to platform things from a data scientist. So, which is why we have Kassu here. So, Kassu, could you share us? I believe you started around the time when we started to evolve this platform idea. So, you have seen the world before the platform, during the platform, and when the platform has matured. How has it been?
Yeah, true. Thanks. Let's say it's been an interesting journey to follow for sure. So, as you said, in logistics, I think we were one of the first, if not the first team to actually implement or sort of to produce a service that was deployed using Sheldon Core. And before that, we also had, few models running in production, but they were like much more custom made. So, you know, they were built as a proper service. The API was self-defined. Training was handled with, you know, whatever it took to get the job done. Monitoring, well, on service level versus on model performance level. As said, everything was pretty custom made. So, you know, talking from having 1, maybe 2 models running in production, and sort of reflecting that with the current setup of having, you know, well, with all the like experimentation variants that we had, we're probably close to, I don't know, 10 models running in production in our team only. So you imagine, you know, you implementing that API, and then after having 10 things, you know, implementing that, you find a bug somewhere and you go like, oh crap, I have to like go and actually downstream this change to all those models is just, you know, unbearable, and something that couldn't have, you know, gone for long. Which is why, you know, contrasting this custom solution that we had, for example, for one model, took my guess is like something between 1 and 2 months to build, to have like the API to like for the service to call for predictions, and then to have the training job, which essentially was just a cron job running at the time, also running on Kubernetes, but still like very custom and very like, yeah, tailor-made solutions. And that took, yeah, between 1 and 2 months. And then after like releasing Selden, and yeah, obviously there's a small learning curve to, you know, understand how the whole thing works and what you actually need to implement and so forth. And since like it was new to everyone in the platform, it's not really maybe comparative taking the first Selden core project that you did, but still that took maybe, what would I say, maybe 2 weeks at most to have the same thing. That was still running with the cron job, taking care of the training because we didn't have Flight at the time, but still, like, I guess that's what it all boils down to with the ML platform, is basically as you grow in scale, you still want to maintain certain quality, and it'd be naive to think that you're, you know, be able to produce the top quality in your first iteration, which is why, like, as the ML platform evolves, it's essential that you can downstream those like improvements in the platform to all the like currently running projects as well. And that's why I've been like a crazy fan of ML platform, really like trying to implement everything that I can as soon as possible, because it really makes my life easier.
Could you share a bit like how is it in practice? Like, how do you as a data scientist use the platform that we are talking about? Like, is it going to some fancy UI, clicking around, or something else?
Yeah, well, I guess there are, yeah, multiple ways I use it currently. But if we start with the serving part, which is basically you have a ready-made model dump that you are able to produce either locally or through some, you know, some job produced it for you. But you have this model dump that, you know, you want to serve somewhere. So this is where basically Selden core would come in, and you would basically implement. Yeah, when I said that you don't have to implement a lot, it doesn't mean you don't have to implement anything. There's just like few function calls that you basically need to take care of, but that's really it. So basically, how do you want your model to be initialized? And then how do you want the predict behavior essentially to be? And you can hook onto this some like pre-processing and post-processing things if you want to. But if, you know, leaving that apart, it would be just, you know, a few functions that you'd implement. So given, you know, some input, what do you need to do with it before you can call the model's predict function? And after you get the output from that, then, you know, how do you want to return it? Is it a JSON, or is it just, you know, an array of values, or like essentially it comes down to that. So that's basically the serving part. So it's made super lightweight in terms of, you know, boilerplate and what you have to implement. But then the other, so that's zero UI clicking from my perspective. Then we go to having something that could actually produce that model dump, which would be, well, formerly the infamous cron jobs, but currently it's like done through flight jobs or flight workflows. And those are the things that you can, have some observability also through the UI that we have. So it essentially enables you to trigger those workflows manually if you wish to do so. Often this is part of the development cycle. So as you're working with the workflow, you work in the development cluster and you want to maybe test that, okay, does it run now? You could run it also locally. Obviously, this is like the first step, but once you get that done, you still want to make sure that you can actually run it on the cluster. So for example, you request enough resources, or in case, your query returns some, I don't know, empty data frame or whatever, then that the workflow can really, cope with that. So you want to test it like end to end in the cluster as well, which is made pretty seamless through the UI clicking. And UI clicking can be a bad thing, but I think like it's like Flight's UI is pretty convenient in my opinion. You don't do like too much like God level stuff. It's just like really simple commands that you can do there. So it doesn't like cover 10 different actions under one click of a button, which is why it's nice. But then essentially having Flight there, you can obviously hook a schedule to your workflow, so you don't have to run it manually in order to have your model retrained. This is where Steven would have had a really hard time selling this to the data scientist in the platform. And to mention, MLflow also enables us to like keep track of how were the past model training. So essentially, every time we like train our model, we also carry out some evaluation to understand that the performance doesn't degrade. For example, if data went missing, something, we might have some signs already during like inference time, so we could see that, okay, the distribution is shifting. But then obviously, if we train a model once a day or something, then if the metrics drop down drastically, then we would definitely notice it, that this is something more permanent maybe. Yeah, maybe that covers it pretty much. One thing that I'm gonna mention, since there was some talk about the number of Flight projects that we currently have at Wolt, I think Flight is probably pretty central piece to everything that we do in terms of data science. Obviously, it's you would say it's not the right tool if you're only exploring data, because it's maybe a bit too heavy and too many steps ahead already at that point if you're doing exploration. But let's say that you're in further down the lane in your explorations, that you want to run, for example, complex model trainings, you want to compare multiple models, or you want to do batch predictions, as Stefan said. It's basically everything comes down to you being able to produce a lot of numerical computation, let it be model fitting or evaluation or whatnot, but still that's why I consider Flight as a really the central piece in our terms. And then obviously some models need this inference server as well, so that they can serve these predictions, but not all models do that. And also you don't maybe want to deploy all models that you train. So if you train, let's say, 20 models and want to see which one is the one that performs the best, then you want to maybe deploy only the one that performs the best, kind of anecdotally.
So as a summary, if I understood correctly, there's some boilerplates, kind of some placeholders to implement, some UI clicking. I assume there's some YAML writing as well. How good of a YAML engineer are you, Kassu?
Let's say I've grown some muscle, especially thank you, Stefan, for that. But yeah, there's definitely some YAML defined or required, and especially if you want to leverage sort of more elaborate features of, for example, Seldon core, then some YAML engineering is needed. But yeah, I guess hard to, you know, avoid YAML in anything you do if you want to run things on Kubernetes and want to be sort of independent in that sense, that you don't go around begging for other people to do it for you.
Yeah, that kind of caught my ear as well. You said like, how much UI clicking is it? But that's kind of the fundamental problem in combining the experimental nature of data science and then software engineering best practices, right? So that you wanna do, it's not like the traditional software engineering tooling or even data engineering tooling would fit the purpose of building machine learning systems, but then you still want to keep the best practices that there are in these industries, like testing and versioning, which are not for granted in this kind of research oriented field like machine learning. And I guess our team's aim is here to provide for the data scientists to work on this iterative and explorative task, like in the tooling that would better fit both them. If for example, if you like compare, Kassu is a fan of Flight, which is pretty cool because, for example, you can have different kind of dependencies for different workflows or even different tasks, which is not possible in Airflow, for example. And then you can cache your outputs and restart your workflows if there's, for example, failures. And this might be actually pretty nice in case you are handling big amounts of data. And then you can version your workflows as well and run previous workflows so you can compare. So it's nicer to work in these kind of tasks with this kind of tooling, I would assume.
Yeah, definitely. So sort of even taking the, I would say, like the core essential of what you just said about versioning is really like crucial in terms of if you want to, you know, if you have multiple people working on the same project, you know, as they always say, but still in our case, it's very much the case that, you know, we sometimes actually have, you know, two like feature requests or something that we're researching under the same project. And then you want to, you know, someone is changing something in a workflow, but you're not maybe ready to adapt to that change yet, but still you have to run your workflows. So it's very convenient that Flight supports like versioning.
So if I understood correctly, this Seldon core is some sort of a component that you use for wrapping your model so that you can serve it, so kind of have some API in front of it. Is that correct?
Yeah, that's essentially what it does. And there's a lot of benefits to it. Like the simplest case we already discussed is essentially you having a model dump and you just want to serve it, you know, to some clients so that you can serve your magnificent model predictions. But then like the other perspective is like there's a lot more to sort of serving model predictions. There's essentially, as we also discussed, it's like developing a machine learning model is an iterative process, which means, you know, by nature you make changes, and it can be, you know, model like model family changes, it can be input changes, it can be many things, but essentially, you know, you figure out those like changes that you want to do. Maybe you want to change your embeddings, the way you sort of describe your input data, whatever. But then once you come to the point that, you know, you have things that you want to propagate to your, you know, actual main model, then you still like, there's a kind of leap of faith in doing it by replacing your model just as it is. And then there's a nice, let's say, way for Seldon to alleviate this problem, by offering almost out of the box shadowing. So as soon as you have, or as long as you have like a common gateway, which is something that, for example, Ambassador, or we can use Ambassador for. So you have a shared gateway for you, like how do you call your model? Then you can basically release your model in a shadow mode, which Selden supports, which means that it essentially becomes like a sidecar to your actual model. But essentially the only thing is that it receives the same like model, it's requested the same way, but the responses of your shadow model are just neglected. So they don't, they don't end up anywhere. But instead, like when you do this, you can have out of the box monitoring for your model. You can see logs, or from the logs, you can see if errors start appearing. So essentially, it's an like end-to-end smoke test where you still, you're already seeing if some things will not work in production. Obviously, we don't want to go there, too soon. But as soon as you would be ready to release, it's a nice intermediate step for you to gain confidence that it actually runs in production. Because when clients call your services, things can be different than what you assume when running your tests and such forth. So it's a nice way, and it's already like it's also, I would say, the way you implement this is it already like points you to taking steps towards having a production solution. So it's never like I don't know, a track that takes you completely to other direction. Damn, I have to implement this shadowing thing and it's a waste of time. And no, it's just essentially you make the changes that you would to the or you would make the main model, but instead you define it as a shadow, and then it's good.
Are there also some facilities to roll out it to also a small portion of the, let's say, end user requests? So some sort of canary support or similar?
Yes, definitely there are. I at least know of 2 ways of doing this, but essentially you can basically promote your shadow model to being a canary model, and you can have, not too familiar with how, like, the fewest YAML changes required would be that you just drop one annotation and add another one, but there's some randomization involved in what Ambassador would be doing at that point, and I'm not too familiar with that, but because the way we've done it, or the way we do it, is we do the randomization elsewhere, and then something that Selden also supports is you can do like header-based routing. So you essentially define it to be under the same like service's name, but still there's some extra bits of information in the header that then allows you, because you use the common gateway for the model calls, then it allows you to actually direct the traffic to the correct deployment as you will. But so for example, this is how we do experimentations if we do model releases, is after making sure that it works in shadow mode, we then make the model a canary deployment, first receiving zero traffic, and then making sure that the canary deployment lights up well, and after that we see everything is cool. We can then add the headers in let's say some fraction of the client requests, and then we immediately start receiving predictions from our canary model. So also from like this technical robustness perspective, this is, I would say, pretty nice. You don't sweat for nothing here.
Yeah, sounds very familiar to a backend engineer listening this. I think in one of the earlier episodes we discussed about splitting a monolith, and shadowing and canaries were actively discussed there. So Yeah, very similar robustness strategies as in the traditional software development.
Exactly. Yeah. Here the sort of twist is that we do this, for every model iteration that we do, because we want to make sure that no model screws up the entire service or whatever. So this is like the way we work, part of that.
Great. Should we move on to like lift a bit our head above the details of the ML platform? So I would be interested to hear how do you collaborate in the ML platform team and all the data scientists that we have, and how the like actual operations work? Are the data scientists on their own? Are you supporting them, or how does it work?
Yeah, well, we aim to be quite customer oriented, so to say. So we see all data scientists and machine learning engineers and teams building these products as our customers. So we don't want to isolate from them. So we have these regular syncs with the teams to have some quality time with them and see where their roadmap is going and what kind of features they would need to be built like within the next year or so. But then in the day-to-day life, we have these Slack channels for each tools where they operate mostly as communities where people can support each other on questions related to flight or Seldon. But also we aim to provide support. We have these rotating support shifts inside our team that last for a day. So on those days, one of us is always available for helping for any kind of problems that there might be. Of course, we are available outside that as well, but we also need to balance with working on new features, and we cannot be just trying to stop fires here and there. But yeah, it's a balance.
Are you getting some contributions back from the users side as well?
Yes, we are getting some. That's really nice. Some users that they might see a bug or something tiny we missed, or even bigger kind of entities that there should be in place. They come to us, and I really like this community feeling that we have, or that we are in the same boat trying to fix these things for all. So definitely there are these users that are really interested also solving the problems for others as well. And if they see something that needs to be fixed, they do it, and we happily review those PRs.
And I would assume the heavy users like Kassu probably are quite a good knowledge base also outside of the ML platform team.
Yeah, I mean, definitely, it's also like that's why we try to also not answer every question from the as a platform team, because the idea is that our ambassadors, if we may say, are also helping other people and sharing their knowledge. Because otherwise we just become a support team, and then it's not really fun on our side as well. And it's also very important to share the knowledge, because Kassu has a perspective on a problem, perspective from a data scientist as well in particular, and that's something that we might not have, might be missing. So it's also good to have ambassadors like that directly.
Yeah, it's also about enforcing these practices. We try to enforce these practices that we see that are really good. Like, for example, if someone asks something, there's a place for direct messages, but something that is a technical problem that maybe someone might tackle with in the future. So it's better to move it in these open channels. And I know there's a barrier that you might be embarrassed or something, but once you get over it, it becomes also as a knowledge base itself. You can look back at the Slack discussions, and if someone else had this problem, maybe reach out to them directly instead of only the platform engineers. So it's also about those enforcing this kind of culture.
and contributing to a doc, because it's also like, like we write the doc, but it's very hard to maintain. It's also one of the things that is always very nice at first, but then when you actually have to maintain it, it can be hard. So it's also like, oh yeah, you encounter a problem, please fix the doc as well, so we can like all do it. And I also say that I like to go on holidays and not be like bothered during it. So it's also a way, like maybe people will work in the morning very early. So then if there's a doc, they can also do it on their own and don't need to wait for the platform team.
Yeah, I love it when someone comes to us like, hey, there was this outdated doc, I fixed the link here or something. And I just love those kind of users.
Sounds like quite a luxury to work so close by your end users or your customers, which can be, of course, good and bad. I don't know, you know better. How about if we look at to the future? So Miia mentioned that I have to balance between support and building new features. So how do you decide what kind of new stuff you will include, and if you can share something, what's cooking in the near future?
Yeah, so of course we can always reflect on what's going on in the industry, what other companies are doing, what's the kind of standard. But then we also need to think about our users, our customers, and in these things that we have, we regularly kind of ask for where the teams are going, and we can from those kind of plans to try to address that there might be these kind of needs, and then and those kind of needs, and then we can see that if there's an emphasis on some things that keep repeating, then we need to take it in our backlog, or that we see that it's not yet a big deal, but this kind of feature needs a long time to build, so let's already address it. So at the moment we have MLflow for experiments and Flight for these ML pipelines, and then Seldon for deploying the models. But then what we are kind of missing at the moment, I would say that the first part that we have already addressed is like before you even start a project, if you would like to check the data a bit, or you want to quickly access some GPU to train some model or explore a bit, so to say. So we have started to build this notebook exploration layer. So we have deployed Jupyter Hub in our Kubernetes clusters for this early phase users. So that's in that way people won't have to, for example, download data to their own laptops to run some stuff there, but they can access it directly and then access some more resources than in their laptop. So that's pretty nice addition. And then another thing is when it comes to real-time predictions and serving, Kassu has some pain from his experiences on this, that in ML there tend to be this kind of skew between training and serving when it comes to the features that are provided to the models. So in some cases you might need the features to be calculated on a more frequent interval, that maybe on a daily basis as batches or so. So we are now addressing this. Some call it a feature store in the industry. We would like to use this Chipwens naming, which is a feature platform. So we are building here now at the moment this feature platform for users to be able to define the features, and also having them available them in low latency in serving phases for the models. So we are first trying to address the kind of online features, so streaming features cases, and then later on the batch features as well in a unified way. So this also aims to kind of reduce the cognitive load for everyone to figure out like what kind of features there have been computed. Like, let's say I don't want to compute again the same heavy compute feature that other teams might be using. So maybe I could reutilize something someone else defined, and then also if there's a standardized way that will already speed up the delivery of your model, that you don't have to figure out your own way to define features. And then we are also working on monitoring part, real-time monitoring in our team. So the aim is to kind of provide way to, for example, compare your model's predictions to ground truth, and then decide if you need to retrain your model if the predictions are starting to differ quite a lot from what you expect, because as said before, the underlying data might change, and that reflects the model performance. Was this a too long answer?
No, this was great, and sounds like we might have a feature platform episode coming up in a couple of years. Who knows?
Yeah, that's definitely going to be an interesting one, and we are joining our efforts with the streaming team that has been launched as well. And
which is a streaming platform, isn't it?
yes.
Great, thanks for the super interesting insights. I think we could end this with if you have any tips for companies or teams elsewhere which might be considering that, right, we might be at the scale where we might want to do a ML platform sort of solution. So do you have any tips for those peeps considering that at the moment?
I think the way to start is usually to address the problem that people have, the main problem they have. Don't try to go for something because from an engineering point of view, you think it's cool. Just try to solve your customer's problem and then take it from there. Don't try to overthink. Just deploy it and have like a couple of users try it and then see if they like it.
Yeah, I agree with Steven. With platforms, you really often fall in the trap of building something cool for the sake of having it. So you go tech first, but you don't think about the users and their problems. So in this thing, you need to go users first. And I like, there's this book called Team Topologies from Matthew Skelton and Manuel Pes that describe platform team that a platform is not about the tools, it's about like the minimal viable platform is a list of things you should do that you can solve a problem. So that's already reducing the cognitive load of the customer team, that they don't have to figure out all the steps, but they can follow the list. So I would go that way forward. And I would also, another thing I would like to add to what Steven said is that I think I really respect data science as a field of work, because it requires you to do to know a lot of from maths and statistics and these kind of things that maybe a software engineer doesn't need to care that much about in their daily work. So I think it's a bit unfair to expect a data scientist to master everything from testing and integration to deployment and everything, to be this end-to-end full stack developer. So if you want to keep your key data scientist, you might want to invest on ML platform team to let them focus on things that are their core competence.
Yeah, so I can fully second what you folk just said, but maybe carrying on also something of, from the eyes of the data scientist is think also MVP style. Like, what is the thing that you actually are going to deliver? Like, what is the deliverable that you want to get out? And, you know, although you might have, you know, great visions of deploying some fancy state-of-the-art models out there, start with, I don't know, creating the service with a simple decision tree or linear regression with some simple features. Just, you know, having the whole thing, if, you know, creating this serving model predictions is, if that's the thing that you want, then, you know, think like small, but think end to end already in the beginning. Like, how does it work? Can I actually call this? Like, what, like, where does the data come from, and such forth, and step by step.
Great, thanks everyone. Hopefully you enjoyed this as well. At least I learned a ton today. So until the next episode, see you. Thank you.
Thank you.
Thank you.
Here, bye.